Hi, welcome to Demystifying Math. In this lesson, we're going to be discussing hyperbolas. We're going to use a geometric definition of a hyperbola. Look at the figure that we have drawn here. We have a hyperbola drawn with two focal points, F1 and F2. And we also have the center of the hyperbola. Notice that the center of the hyperbola is halfway between the two focal points. We also have a point P1 drawn on a hyperbola here. And then we've drawn lengths from F1 to P1 and from the second focal point to the point P. These lengths R1 and R2 help us define the hyperbola, and that is because the difference between R2 and R1 is always the same no matter where point P1 is on the hyperbola. Let's look at this. Okay, so here's our point P1 drawn on our hyperbola. We have measured the length of R1, which is right now 3.89, and we measured the length of R2, which is 9.89, and we found the difference between R2 and R1 to be 6. Now notice that as I move point P1 anywhere on the hyperbola, the difference between those two lengths is going to always be the same, in this case 6. So even as I come in toward the vertex, the difference between those lengths is still 6. No matter where I am on the hyperbola, those lengths are difference between R1 and R2 is 6. Now you could imagine that if point P1 was on the other branch of the hyperbola, we would still have a difference between R2 and R1 to be 6. The only difference is that R1 would be longer and R2 would be shorter. Okay, so when your focal point line up horizontally, the center point is halfway in between them, so all three of those points will line up horizontally. And when they do, the line that goes through those 3 points is called the transverse axis. And it is a line of symmetry for the hyperbola. The hyperbola also has a second line of symmetry that is perpendicular to the transverse axis, and we call that one the conjugate axis. Notice that it also goes through the center of the hyperbola. Now, on the transverse axis, you will also find what we call the vertices of the hyperbola. Now, when you do have a horizontal transverse axis, the equation of the hyperbola becomes x minus h squared over a squared minus y minus k squared over b squared equal 1. You should recognize that formula as being very similar to that of an ellipse. The only difference between this equation and that of an ellipse is that there is a minus sign in between the two terms, whereas with an ellipse there was a positive sign in between the two terms. Now, you could also have a hyperbola with a vertical transverse axis, and that equation is y minus k squared over a squared minus x minus h squared over b squared equals 1. Now, the way that you can easily decide whether your hyperbola has a vertical or horizontal transverse axis is by looking to see which term is positive. So in the one that has a horizontal transverse axis, x is positive, and for the other one where you have a vertical transverse axis, y is positive. Remember that on the transverse axis you will find the vertices and the focal points as well as the center of the hyperbola. Remember that your center is going to be represented by HK, and A and B are going to help us to find our asymptotes. So let's go ahead and do that. Your asymptotes will go through the center of the hyperbola, which is your HK, and the slopes can easily be found by looking at your equation for the hyperbola. So remember that slope is rise over run. So we're looking at the value under y as being our rise, and the value under x as being our run. Now, with your asymptotes, they have the opposite signs, so we put plus or minus. One's going to be positive slope, and the other one's going to have a negative slope. And they both go through the center, so once you have found your center, then you can just use your rise over your run and go in all 4 directions and find 2 asymptotes with at least 2 or 3 points on each one of them. Then you could also find the equation for your asymptote simply by using your point-slope formula. So we have our slope, in this case, is b over a minus times x minus h plus k. Remember, h and k are your center, which is a point in common to both of your asymptotes. Now, if you have a vertical transverse axis, it's not that different. It's just that what's under y is now called a, and what's under x is now called b. So your slopes are going to be plus or minus a over b. But again, they will go through the center of the hyperbola, and then you just find your rise and your run, and you can plot them. Of course, your equation is just going to be the reciprocal of the slope of the other one. Okay, an easy way for you to plot your asymptotes is to first find your center point. So this center point here is going to be at hk. And then we're going to use what's under y as our rise, and what's under x as our run. And we can run in the positive direction or the negative direction. So we're going to go over here in the negative direction, and that gives us a point on this asymptote. Remember, it's going to go through the center, and it's going to go through that point after you've rised A and run B. Of course, we could rise A and run B in the positive direction. That's going to give us our other asymptote. Remember, these asymptotes have opposite slopes, one positive and one negative. Our other choice, we could, instead of rising A, we could go down A and then left or right B, and we would find our asymptotes. Okay, so now what we want to do is give an equation for a hyperbola that has a vertical transverse axis and has a center at 2, 4, and our a value is 2 and our b value is 3. Alright, so the first thing that we need to do is decide which equation we need to use. Since it has a vertical transverse axis, we're going to use the equation where the y value is positive. Then we can plug in our center point at 2, 4. Remember, 2 is an x value and 4 is a y value, so no matter what order you have your equation in, the 2 goes next to x and the 4 goes next to the y. Then our a is 2 and our b is 3, so we plug that in and simplified. So we get the equation y minus 4 all squared over 4 minus x minus 2 all squared over 9 equals 1. Now what we want to do is simplify this. So we're going to FOIL out the x minus 4 squared, which gave us y squared minus 8y plus 16. And we're going to square the x minus 2, which gives us x squared minus 4x plus 4. Then what I'm going to do next is multiply everything by 36, which is our common denominator, to clear out the fractions. And distributing the 9, and then distributing the 4, and multiplying 4 by 9 on the right side. Then I brought together my constants and set it equal to 0. And I also reordered, putting the x squared term first, then the y squared term, then the x and the y term, and then lastly the constant. So this is in our standard form where we have a is negative 4, c is 9, d is 16, e is negative 72, and f is 92. Notice that with a hyperbola, because we have the minus sign in between the terms, your a times your c value should always be negative if it's a hyperbola. Okay, let's now try to graph one. We have x minus 1 squared over 36 minus y plus 3 squared over 9 equals 1. The first thing that you should notice is that your center is at 1, 3. And then we want to find our vertices. Now this one is a hyperbola that has a horizontal transverse axis. So the vertices are going to be plus or minus 6 units away from the center. So it's 7, negative 3, and negative 5, negative 3. Then we want to be able to draw our asymptotes. So we need to find the slope of the hyperbola. We know where our center is, and our slopes are going to be, in this case, the square root of 9, which is 3, over the square root of 36, which is 6, or plus or minus 1/2. And then we can go ahead and sketch our hyperbola. Starting with our asymptotes, we plot the point at the center, and then we're going to rise 3 and run over 6. So that's going to give us a point at negative 5, 0, and another one at 7, 0. So we have those two. And then of course we could go down 3 and over 6. I like to use the unsimplified form of the fraction because it's going to help me find my vertices as well. So the vertices are here, so I'm going over this direction 6 and getting to -5, and I'm going from the center to the right, and I'm ending up at 7, -3. So I have my vertices and I have my asymptotes. Now, we also have a formula to find the foci of a hyperbola, which is simply a squared plus b squared equals c squared, where c is the distance from the center to a focal point, and your a and b are in your denominators. Okay, so for this particular problem, a is 6 and b is 3. So we're going to plug that into the a squared plus b squared equals c squared and isolate c. So c is the plus or minus the square root of 5 times 3. So we're going to add and subtract that value from our x value. Remember, the foci are going to line up on the transverse axis along with the vertices. So from your center point of 1 and -3, we're going to use the 1 value because it's going to be a horizontal line up. And then we can plot those points. And I just went ahead and estimated them so I could plot them more clearly. Remember that one way to check your work is that your foci are going to be always on the inside of the curve of your graphs. Okay, let's talk a little bit about eccentricity. Eccentricity is defined as c over a. Again, the c is the distance from the center to the focal point, and a is the distance from the center to a vertex. Since the foci are further away from the center than the vertex is, c over a is always going to be greater than 1 for a hyperbola. Let's take a look at this in detail. Okay, so here we have a hyperbola drawn, and I've calculated the eccentricity. So remember that c squared equals a squared plus b squared. So I just isolated c in my exponent by replacing it with the square root of a squared plus b squared. Now what we want to do is see what happens as we change the values of a and b. So let's go ahead and change this value here. We're changing b, and that means that we're also changing the eccentricity. And as I'm changing b, notice that my eccentricity is getting larger. And look what happens to my graph. It's kind of straightening out, right? It's not as curvy as it was before. So as your eccentricity gets larger, the focal points move further away from the center point and from the vertices. And at the same time, the graph is getting straighter. Now we can go back and bring it back in, and you can start to see that it's going to come in and look a little bit more curved there. And also at the same time, the focal point are closer to the vertices because that ratio is almost 1 at this point. They're almost the same. Okay, so you can get an idea of what the eccentricity means when we're talking about a hyperbola. Okay, thank you for tuning in to Demystifying Math.